that removing its door is a criminal offense under California.
It's amazing.
Told you.
Well done. Well done.
I
All right,
don't
here we
think
go.
this
So
stuff-
start graphing after you get the GeoGebra, and let's get out the, recover. Oh yeah, look at that.
Jesus.
I worked on something like I got yesterday. Yeah, it's kind of fun.
Daddy, are you going to
Alrighty. It's not for you, this is for regular geometry. Let's refresh what we learned the other day. So, we talked about, and we've been doing this for a while, the medians in a triangle, right? Real quick, what's a median? Someone other than Alex. Alex got it last time. Go.
Where the vertex and the midpoint
Intersect, that's right.
Yeah.
So we have a segment between the vertex and a midpoint, right? That's a midpoint. A vertex and another midpoint. Those are medians. In the middle, what's that called where they intersect? The medians intersect. Go.
Centroid.
Centroid. She's on fire.
Oh my goodness.
No jokes about Australia. Not
It's all
appropriate.
the class.
Not appropriate.
Is that, it's not even burning anymore.
Not appropriate. All right. So that's the centroid. Cool. And we know that this will be double whatever that is, right? Cool. That's another thing. So if that's 2, this is 1. If that's 6, this is 3, right? Something like that. So we learned about the intersection of the centroids. We have the medians. And of course, medians are vertex. Bless you, child, to midpoint.
You have influence of
Then we talked about angle bisectors yesterday.
You're dead.
After we learned how to make segments and all that crap, right? We got barely into angle bisectors. That's what that is up there. We're going to talk about angle bisectors today. And a little bit more. All right, so angle bisector is something like this. So it's where you go from the vertex and you cut that angle in 2, right? That's what bisect means. Angle bisector means something that cuts an angle in 2. So that means this angle and that angle will be the same. I'm only going to draw 2. I can draw 3, but it just makes my drawing messier. Then these angles will be the same. And where they intersect is called the incenter. Now, these don't really have botanical properties about them like this, like they don't have that clear cut. It's going to be different for every triangle, right? But the angle bisectors cut the angle in 2. Where they intersect is the incenter. Now, what's cool about the incenter, as you can see up here, I've got a bisected angle here, a bisected angle here, and a bisected angle there. They all intersect at point D. That's the incenter. The incenter is always inside the triangle. That's why we call it the incenter. And it is the center of a circle, actually, that perfectly fits inside the triangle. So if you have like a triangular box and for some reason you need to put a basketball in it, right, or some kind of ball, you can find out exactly how big that ball could be and no more. That's the perfect amount that takes up. So what happens is this circle barely touches that corner right there, and barely touches this side right here, and barely touches this side right here at points E, G, and F. Okay? So that center, D, where all of those intersect, the incenter, is the center of a circle that perfectly fits inside the triangle. When something perfectly fits inside something, we call that inscribed. Inscribed. Okay? Does that make sense? Scribe means to write, in means inside. So we have an inscribed circle. And I'm going to be terrible at drawing it here, but there it is. So the incenter is the center of an inscribed circle in a triangle. And this is true for any triangle that you make. So if I drag these points around, where's my mouse? There it is. Oh, I need to duplicate my screen. Hold on a second, guys. Instead of looking up there. Duplicate. There we go. Uh-oh. Great album. Radiohead, Hail to the Thief. Why is it not showing the same thing that I'm seeing? Duplicate. Oh, keep. There we go. Alright, so check it out. If I get my pointer tool out, my move tool, I can drag this around, and no matter what my triangle is, the circle's always inside, right? Cool. Alright, let's practice making this. So I'm going to delete all this. Here's what we're going to do. Make yourself a triangle if you haven't done so already. Everybody know how to use the segment tool to make a triangle? What I want you to do, because we're going to have a lot of lines on this screen, is after you're done making your triangle, right-click your segments and go to Settings, and change the color. I'm going to change mine so they're all blue. So again, I'm going to click the segment, right-click, go to Settings, Color, blue. Uh-oh, it's being dumb again.
Where's mine up weird?
Well, let me refresh. If I have one complaint about a GeoGebra, it's that it gets stuck on stuff. So I'll do segment, segment. So click the segment, right-click the segment, choose your color in setting. Does everybody have a blue triangle or something like that? Anybody need any help creating it? Nope. Everybody's peachy? Great. All right, so now what we're going to do is we're going to create some angle bisectors, right? Because that's what makes the incenter. So an angle bisector, you go to Construct, and you're going to grab the angle bisector tool. And it says select 3 points or 2 lines. Select 3 points. Remember, if you want to bisect a certain angle, the second point you choose has to be that angle's vertex. So if I want to bisect angle A, I can click B, A, C. And that'll cut angle A into 2 equal pieces. I can then cut B into 2 equal pieces by choosing A, B, C. And then lastly, I can cut C, A, C, B. Where those intersect, put a point, and right-click that point and change its color to something visible. I'm going to choose red. So that red point right there is the incenter of my triangle. It's the intersection of all of my angle bisectors. Right? All of those lines cut their angles in half. See how everybody's doing. Doing okay? Well, make sure you try it on your own, because I want to make sure you guys know how to use GeoGebra, because my thought is that we're going to use this on a quiz soon. Or I'll have you guys construct this stuff on there. For a while, I wanted you guys to do it, start opening this up, guys. For a while, I wanted you guys to do this on pen and paper, right, with protractors and compass and all that, but let's be honest, our compasses suck, right? They really do. Remember when we got those out and like bisected a segment and all that, and we drew the pictures with them, right? It was garbage. I want to see if you guys can do it on here. I think that's a much more fair way of assessing it. It doesn't require you to have amazing protractor and compass like Corinne has over there in the corner. Yep. You got a question? Yep, create those segments, and then right-click to change their color so it's something visible. So you got your triangle, Tucker?
Mine don't even make a line.
See if I can zoom in.
This
Ooh,
website,
that's better.
I mean,
Okay.
actual.
You guys need help?
Mine doesn't even work.
Doesn't even work?
I don't know how to use it.
Is it being stupid? Because if it is, then you're going to have to refresh, and that really sucks. Yeah, just refresh. Get a new page.
Alright, now I need help.
All right, so Tucker, I'm going to try and help you from up here. If that doesn't work, I'll come back, okay? Do you have your triangle?
Yep.
Okay, so now what you're going to do is you're going to make the angle bisector. So let me delete mine, and I'll show you how I made it. Right, so there's my triangle, right? I'm going to go down to construct and choose angle bisector. Remember, angle bisector means to cut an angle in half, right? So it's going to ask you after you click it, what angle you want to cut in half. So if I want to cut angle A, I need to make sure I choose that as my second point, right? So like B, A, then C, right? So if I do that, B, A, then it knows I'm talking about that angle, right? And it'll cut that in half. Cool?
So I'll just do like BA.
Yeah, BAC or CAB.
And then just put the line anywhere or what?
Nope, the line will automatically be done for you. So I'll go B,
Well, why is the line be moving?
A, and then click C last. You have to choose 3 points. Did you click BA then C? After that, the line should stay still.
Alright.
Good, good, good. You're going to do that for all 3 angles. So again, grab your angle bisector. Now I'm going to do B, so I'm going to do ABC in that order. So that tells it to bisect ABC, that angle, right? And then I'm going to have it bisect angle ACB.
So I'm gonna have 3 lines, right?
Yeah. All of which cut their own angle into 2 equal pieces, right? After you get that, after you get that, go up to the top and put a point where they all intersect. Right click that point and change its color to something visible. I'm going to make mine red.
So let me change it. Wait, hold on. Just kidding.
Left click so it knows you're talking about it, and then right click it. That sometimes helps. Alright, so check it out. No matter what I do to my triangle, the in-center, point D, is always inside it, right? And that's because it's the center of a circle that perfectly fits inside the triangle. So of course it would always be inside, right? If the circle's inside, then the center will be inside. How are we feeling? Good? Wonderful. All right. Can you get your angle bisectors for me? Awesome. Rad. Great. Super cool. Amazing. Fantastic. Excellent. Beautiful. Oh yeah, there's a triangle. We're getting there. Took them a while, but we figured out 3 angles makes 3 sides. What we got? Maddie!
Sorry.
It's alright, like your nails.
I don't even know how to make the lines.
Oh boy. Alright, here's what I need you to do.
Yesterday.
Alright.
I don't know how to work
I got you. Starting up from the beginning. This is the last time I'm going to do it. So if you don't have the stuff on your page, now's the time to watch. Not mad. I just want to show you how to do it. So first things first, create your triangle. You want to go to the segment tool, go down to the bottom and go to lines, where it shows a segment, right?
Wait.
Then do CBA.
Segment?
Yep. See how it goes? I went all the way down to the bottom where it says lines.
It won't let me scroll down.
You have to pull your thing out, and then you have to like try and grab the scroll as fast as you can. That's what I've been doing all the time.
Yeah.
Did you get it?
Our Chromebooks being dumb.
Yeah.
My Chromebook's always done.
Everybody needs a mouse. Like that should come with your Chromebook. That would make things so much easier.
I have.
Mouse is superior form of technology.
Oh my gosh, it literally just came.
Here, like, you have to like pull it, and then like right when it comes up, you have to like try and get it. See?
What?
What?
Are you guys having the same issue with your Chromebooks? With the scrolling? Or no?
I do.
Yeah.
Oh. Oh.
Let me see. Nice boots too, jeez. Alright. Oh god. So it has to be this big that you can get there.
You figured it out. How'd you do that?
Okay, so like,
2-finger scroll.
Oh.
Guys, you guys know that 2 fingers on the trackpad lets you scroll, right?
Wait, no, it's not.
It's not?
Oh, just kidding.
Okay.
Like zoom in and zoom
I
out.
don't know.
Yeah, well, 2 fingers on there and you move them both at the same time. So if you go over here and click it, then it'll let you control that. Otherwise, it thinks you want to control this,
it
right?
has a good song.
Does that make sense?
Yeah.
Okay. Is everybody good now?
Yes.
On that, I'm glad we talked about that. Yeah, that would be a nightmare to have to. Yeah. Oh, gross. Ivy, God bless you. Wow. Taking one for the team for so long. All right. So go down to segment and click it. And it says select 2 points or positions. So what we're going to do is we're going to click 2 random points. And it's going to create A. And if you go to click another one, it'll create B.
Wow.
I know,
I
right?
don't even have like
number 1.
Did I go?
Ivy is MVP.
Oh wait, is that right?
I don't know. Here, don't yell at me. I'm not. Did I?
She's yelling. I can hear her all the way from here. She's so mad.
Just click it. You can. do
Ivy,
it
calm
anywhere.
down.
Oh, I thought
And
they
then
had to
just-
be in a certain
No,
spot.
you can just do it anywhere.
Wow.
I'm like, I don't even
Wow,
have any
listen
of the
to
numbers.
her. Student disruption. Ivy Van Campen yelling at student. Furious. Through chair. Expletives. There might have been a knife.
I
All right.
cried the last time I got a detention, so I was in 7th grade.
All right. Do you have a segment? Maddie's? Okay. Now make another one. Click B. Make another one so you have BC.
I made a triangle.
Oh, you did?
Yeah.
Okay, look, overachiever. Calm down.
Sorry.
You got a triangle too, Maddie? Wow. Okay, so now we've got a triangle. Now go to construct and click angle bisector. It says select 3 points. So what you're going to do is you're going to click 3 points. Now if you want to bisect angle A, you have to choose angle A as your third or your second point, right? So check it out, ladies. I'm going to click B, A, C, and after I do that, it'll lock in that line, and that line cuts this angle perfectly in half. I'm going to do it again. If I want to cut B, I'm going to go A, B is my second point, and then C. You could also done CBA. That's fine. To get C, I'm going to go A, C, B. The key is if you want that vertex's angle to be cut, it has to be the second dot you click, right? Because that's how we talk about angles, right? The vertex always goes in the middle. How you doing, Eats?
I got it.
Does your triangle have 3 sides?
Yeah.
Oh my god. Right.
I don't want to
Find angle bisector yet. Yeah, let's select
Friday we did?
C. Oh wait. I'm gonna hit this and then I'm gonna go and
What do we have at this 105 dismissal on Friday for?
do C. A.
It's one of those 105 early outs on a Friday.
If you want to go
instead
through
of
that point, it
Wednesday.
has to be the second one you click. Right? Because it's talking about the
Yeah.
angle. Right?
Yeah.
C.
Meetings.
Right, cool.
Yeah.
All right. After you've got your angle bisectors, drop a point where they intersect. So go up to the top of the menu, and it'll say point, and put in a point at their intersection. So I'll click that, and I'll put in a point. After you have that point, ladies, right-click that and change its color so you can see it. I'm going to make it red. Cool?
I don't even have that.
So all the way at the top, point under basic tools, right? Put it in.
I don't have that many lines though.
You only have, how many
My
you got?
lines are all weird. I don't know. I'm just gonna refresh and do it all over. Cute.
Wait, there's just going on.
All right, while she's refreshing, everybody else, now we're going to go down to construct, or not construct, go down to circles. We're going to create a circle. So it says circle with center through. So it said select your center, then a point that you want on your circle. Well, if you notice, in order to do that, I can click D as the center, but I don't really know where I want that circle to be. It depends on your triangle, right? It might look like it's always on that line, but it might not be. It might be over here somewhere, depending on your triangle. So let me get rid of this one, and I'll show you a more complex triangle, like this. If I try to do the circle tool, right, it's kind of hard to get that to match up. So here's what we're going to do. We need to figure out what the radius of this circle is. So in other words, we need to figure out the height of our triangle, at least from here to here. So here's what we're going to do. We're going to get a perpendicular tool. So go to construct and click perpendicular line. I'm going to click the center, D, and then click the opposite side. And that'll create a perpendicular from there to there. So that hits at 90. So the distance from D to this side is from here to here, right? And that's going to be the radius of our circle. So did you see how it hit that opposite side at 90? I'm going to color that line differently so you can see it. Yeah, you can't see that.
I can see it.
Maybe like bright purple or something. There we go. All right, so I made that perpendicular. If you weren't watching or don't know what I did, here's what I did. I went to perpendicular line, I clicked D, and then I chose a side that I want to make a 90 degree with. So I did that. So that line hits this side at 90. Okay?
I'm just gonna watch because my combo's going stupid.
Okay, that's fine. I'm going to change that to purple so you can see it. That hits the opposite side at 90. That right there is going to be the radius of our circle. So that dot right here is going to be what we make our circle with. So go to the circle tool now, circle with center through. We're going to click D as the center. And then we're going to click where that purple line intersects our other line. And that's going to be the radius. And if you notice, right, if I line it up with that, it makes a circle that perfectly fits inside the triangle. So now, when I drag this around, you'll notice the circle always stays inside the triangle. So we had to figure out how big to make our circle, right? Notice that the radius isn't always one of these guys. Like this line right here, it's longer than the radius of our circle. Does everybody see this on mine? This line right here is longer than the radius of our circle, right? So we have to figure out how big the circle has to be, and the way we do this, we make it perpendicular, right? So real quick up here. If we know that this is the in-center, we're going to want to make a perpendicular line to this side. Nope. Need a giant protractor. Like that. And that will be the radius of our circle. So I go from here to here. It's like that's 90. Yes, you may. It's 90 here. Looks like that's 90. And that will be the radius of our circle. Something like that. Okay? On here I made 3 of them. You only need 1, right? Yes? Yep. So I'm going to get my pointer tool and I'm going to get rid of my circle. So I'm going to click it and delete. I'm going to get rid of this. So you've got a triangle that looks like this, right? We've got all the angle bisectors and we found D. Okay. So now what I'm going to do is I need to figure out how big the circle needs to be, right? I know that's the center, but how big do I make it, right? So what I'm going to do is I'm going to go to perpendicular line under construct. And I'm going to make a perpendicular line from D to one of my sides. So this time I'll choose D and then my side AB. And it'll create this line, which I'll color in so you can see better. This line right here. And that hits this side at 90. So Alex, what I did is I went perpendicular line, right? I chose this. Then I clicked D and then a side that I wanted, and it is going to make a perpendicular here. From D to that point is the radius of my circle. You got that? So what I'm going to do is I'm going to go to the circle tool now. I'm going to choose D as the center, and that is a point on my circle. So now when I drag this stuff around, the circle's always inside. How do I what? Make a circle? Circle tool. So if you go down to where it says circles, let me delete mine. Circle with center through. It says choose your center, then a point that you want on your circle. And I want that point right there. Okay? Notice that a lot of the times it looks like our circle's going to be on the bisector, but it's not, right? Here's my bisector. It's longer than my radius, right? So I had to figure out what the radius is, and I do that by drawing a perpendicular. So the bisectors get me the center, and then the perpendiculars get me the radius. Does that make sense? Okay, cool. How are we feeling about making that circle? You okay? Nice. Again, using that that perpendicular to find the radius is really essential. Reminds me like the Deathly Hallows thing. Rad, fantastic. All right, so eats, instead of shooting to make sure it lines up, what you want to do is make a perpendicular between D and one of your sides. So here are your circles. Click the perpendicular tool down. Yeah, perpendicular line. Click D on one of your sides. Okay, so that made a 90-degree angle with that. It's really simple to the other one. Here, let's drag the triangle around a little bit so it's not so similar. Okay. So there's the perpendicular. I'm not changing its color. That way you can see what's going on here. Purple. So now I know my circle's going to go from there to there. Right? So now go to your circle tool. First one. And choose your center, D. And then where the purple intersects your side is going to be the circle. Well, the other way, a lot of times what you'll do is you'll think, oh, it needs to go to there because of this body and circle too big. They're not the same, yeah. I know when I made this stuff, like when I used to do it with pen and paper, I'd always think that because they're usually really close, those two lines, right? But they're not the same. All right, cool. So that's the in-center, which is the center of an inscribed circle inside the triangle. And no matter what kind of triangle you have, the circle will always be in the middle, even if it's something crazy like this. Cool. All right. Your lovely creation is going to die now. I'm sorry. Get rid of your circle, get rid of D, get rid of your bisectors. Get back to a regular, old triangle. All right, let's talk about some more. I think yesterday we talked about altitude, right? A lot of names for these. What's another name for an altitude of a triangle? The height. Give me another name.
Length?
Nope.
What?
I mean, potato, potato. Height, length, same thing, basically.
Oh yeah.
You see what I'm saying, right? Depends on which way you look at it, right? Give me another name. Anybody remember another? Altitude, the height.
Ascending.
Ooh, that's good, but that's not one we use. Very good though.
Rise.
How do I know that this is the height of the triangle and not this?
Because the angle goes down to a 90-degree angle.
Yeah! Exactly.
Perpendicular.
Well done. Perpendicular. What's another one?
Big word.
Big word. It starts with an L.
Vertex.
Has something to do with the braces bus.
The what now?
Braces bus?
Whatever you said sounded like
It's not orthobus, but it's similar to that.
I don't want to pronounce it, but you said it yesterday.
Something like
You
orthodontist,
said it yesterday.
right?
Orthopedic.
Orthodontics.
Nope.
Orthopedic.
Nope. Orthogonal. Like
Same
diagonal,
difference.
but orthogonal. Diagonal means like at an angle, right? Orthogonal means 90 degrees.
You expect us to remember that?
Yeah!
Orthogonal.
I can't even remember what I read in the book.
What is the orthodontist's goal? To make your teeth
Straight.
straight up and down.
That didn't work for me though.
Legend. Legend.
Probably because I didn't work.
Pulling it all together like that. MVP.
That's how you remember those kinds of words.
You should be the MVP.
She is.
I am voting for you.
Altitude, height, perpendicular, orthogonal, first ballot Hall of Famer. Guaranteed. With GOAT. Greatest of all time. Altitude, height, perpendicular, orthogonal. All the same thing. Can I think of another? I thought I had another one earlier for 5. Altitude, height, perpendicular, orthogonal. We only had 4 yesterday. Did I just make up a 5th one? Anyway, we'll go with 4. The one I really want you to pay attention to are really like, well, I want you to pay attention to all of them. But the orthogonal word will help you remember what the center is that happens when you connect them all. Right? That's 90, and then this is going to hit at 90, more or less. That center is the orthocenter. It's where you get your teeth straightened. Going to the orthocenter on the braces bus. So it's the center of all the orthogonals, right? Of all the right angles. So it's vertex to opposite side at a 90 degree, right? Cool. We can make those really quickly. We did that yesterday, but some of us were absent. Hi.
Where did Maddie go?
Yeah, I know. Doc is ill, the irony. All right.
Nah, he's chilling with old boy right now.
Perpendicular line, let's make them. Click perpendicular line for construct. Click a point and an opposite side, and it'll make a 90 degree. That's where it hits at 90. Not always does it cut it in half.
Wait, what'd you do?
I made it perpendicular.
Do you want to see
She's
that?
waving at you. She's like, I'm not getting up.
Yeah.
I'll say hi. I see you. Hello. Have a good time. What's that?
It's right in front of your door.
3M.
Recycling bin. I was like, it's like what
It's like one of those Fungo Pop car things. You know what I mean? Someone's trying to tell me something. I got a magnetic one. All right. Anyway, so what I did is I click perpendicular line. I clicked a vertex, and then I clicked the opposite side, and it made a 90 degree with it. Notice the 90s don't cut it in half always, right? We didn't say anything about midpoint. All we said is it has to hit it at 90. If that moved over, it wouldn't be 90 anymore, right? So for instance, that's 90. Does it cut it in half? No, that's the height of the triangle, right? We didn't say anything about midpoints. A lot of times it'll look close to half, right? Sometimes it will be. But that's a coincidence. All we're worried about is vertex to 90. And that's the height. I'm going to make my third one by doing a perpendicular. B to the opposite side. Where those intersect, put a point. Right click. Make it red so we can see it. All right. This is not the center of a circle inside the triangle, obviously, right?
That's a bit much.
But if you move stuff around,
They wouldn't have had to call it.
does D always stay inside the triangle?
Nope.
No. From yesterday, when is D inside the triangle and when isn't it?
Isn't
We
it-
have three types of triangles. An acute triangle, right, where all the angles are acute. We have a right triangle where one of the angles is right. And we have an obtuse triangle where one of the angles is obtuse.
Isn't it when it's acute, it's inside?
Yep, acute is inside, and you can check that for yourself with GeoGebra. Right now I have an acute angle triangle. All of those are less than 90, so it's inside. The closer I get to making this angle B, to 90, the closer I get to this. What happens when it's exactly 90? Oh man, I can't do it anymore. Where does it end up? On the vertex, right? So if it's 90 exactly, it's on the 90-degree vertex. And then if we follow that logic, right, acute's here. As we get more and more towards 90, we get here. If we get bigger than 90, where's it going to end up? On the outside. So that's an obtuse triangle. Angle C is obtuse. And so D is on the outside, as expected. Cool. So that's the orthocenter. Just for fun, grab your circle tool make D the center of a circle. If you go to B, does the circle also go through A?
No.
No, it doesn't. So it's not the center of a cool circle. Sorry. But we are going to use it later for circles. So no cool center with B, or with D. No hidden circle. All right, let's move on and do another one. It's close though, right? Close to being center of a circle. Get yourself a regular triangle. All right, we've done medians, which is connecting the midpoint to the vertex, right? We've done angle bisectors, which is vertex cutting the angle in half. We've gone from vertex to 90. Let's talk about this one. I'm going to write it over here. Actually, let me get rid of this. Eraser. All right. So this one, what we're going to do is we're going to do what we did before by getting a 90 degree, but we're also going to cut it in half. So we're kind of combining the median thing, right, with the midpoint, and then this guy with the 90s. So we call it a perpendicular bisector, right? Perpendicular, 90 degree. Bisector because it's going to cut something in half. It's not going to cut the angle in half, but that's an angle bisector. A regular bisector cuts a side in half, right? So pick a side and cut it in half. Let's do that. We need to find a midpoint. Click midpoint or center for construct. And we're going to click 2 points and find the midpoint between them. I'm going to click A and B. That gives me D. D is a midpoint. I'm going to make that blue. Actually, all the others are blue. Let's do purple again. Purpley pink. All right. D is the midpoint between A and B. No matter what you do with your triangle, it's always the middle. Right? Cool. We're going to go from the midpoint. See how this one went from vertex to 90, right? We're going to go midpoint to 90. Now, if you notice on my triangle over here, if I go 90 degrees up, does it hit the other vertex? No, it doesn't. And that's okay. Sometimes that doesn't work. So we're going to create a perpendicular from D. You know how to do that. Perpendicular line, click D. We want that to be perpendicular. So what we're going to do is, I think we're going to click this line right here, and it'll create a perpendicular to that line. So I click D, and then I click segment AB. And that gives me a perpendicular to AB that goes through point D. Now notice that 90 does cut this in half, right? This side in half, and hits it at 90. But does it go across to the other vertex? No. Perpendicular bisectors are kind of the weird one, right? This is the one you're always like, how do I make it be half and 90? Just let it go straight up. Okay? Don't worry about connecting it to the vertex. So these are perpendicular bisectors. Bisector because they cut a side in half. Perpendicular because they hit it at 90. Let's find the center that's formed with these perpendicular bisectors, because all perpendicular bisectors will intersect. Create 2 more perpendicular bisectors. First, find your midpoint of the other sides. And then take those midpoints and make 90 degrees from there. Maddie?
What?
You raising your hand?
No.
They should all intersect at a point. If you need to, move your triangle around so it intersects inside the triangle. Spoilers, if it's acute, it'll be inside. All right. So G is the intersection of the perpendicular bisectors, yeah?
Mine intersects weird.
Is it outside the triangle?
It's right on the line.
Ooh, make it acute, not 90. You have a right triangle? Yep. It's similar to this one, right? Where sometimes it's outside, sometimes it's inside, sometimes it's right on the 90, right? And Tucker, when you had 90, where did it end up? It's like right in the middle of the line, didn't it?
Yeah. Yes, it was.
So an acute triangle,
Now it's down there.
it's on the inside. An acute triangle has it on the inside. Tucker was experimenting on a right triangle. It's on the midpoint, isn't it? It cuts the other side in half, right? So if A is a 90-degree angle, then BC is going to be cut in half by that. You guys see that? My A is a 90-degree. And so where does my center end up? It ends up on the hypotenuse, the halfway point. So acute's inside. A right triangle, if I've got this, it's going to end up right there. Right? Acute will be inside, kind of like this guy. And then obtuse, what happens to it? What happens when you have an obtuse triangle?
It's on the outside.
On the outside, thank you, Tucker. Drag this around, make an obtuse angle. Now it's on the outside of the triangle. All right, so now for fun, let's see if we can find any circles. Go to your circle tool, click G as your center, and move to one of your points on your triangle, one of your vertices. Try the midpoints too if you want. Right, if I go to my midpoint, it's not really that interesting, right? It hits one of the midpoints but not the others. But what happens if you go to one of the vertices?
What do you mean?
So check it out. I'm messing around with the circle tool, right?
Yeah.
So here's my circle tool. Make G, or whatever your center is, right? Make that the center of the circle. If I go to here, not very interesting. If I go to here, the midpoint's not very interesting, right? But if I go to like B, A, or C, what do you notice? It perfectly hits all of them, right? So I'm going to make that circle a little bit more interesting looking. Let's make it red. So the center here for the perpendicular bisectors, where they'll hit that weird one, right? Wherever that dot is, that center is, makes a circle. Is the circle inside or outside the triangle?
Outside.
It's outside. Let's mess with the triangle to see what happens to it. If I mess with the triangle, does the circle ever go inside? No, right? We call this the circumcenter. Careful how you say that one.
Your word's not mine.
That's right. If you go to the orthocenter to get your orthodontics, what do you get at the circumcenter? All right. So a circumscribed circle or a circumscribed square or a circumscribed shape is something that goes on the outside of something. Does that make sense?
Yes.
So inscribed inside, circumscribed outside. So this is the circumcenter. It's the intersection of the perpendicular bisectors, the weird looking ones. Right? Perpendicular bisects. The weird looking ones, the circumcenter. There's a joke being made there. All right. How do you feel?
Pretty good.
On Friday, we'll be having a quiz that'll be Chromebooks, and it'll be, hey, here's a list of things I want you to make. Make it on your Chromebook, like we've been doing here, and then screenshot it and send it to me. You need to know how to do this stuff. If you need help, I can help you. Preferably ask for help during class, but I can also help you during homework. Goodbye. Plan is, quiz will be like this, and then also facts about stuff, like what is the circumcenter, etc., right? Where are they located, if the triangle's this, basic stuff like that. But I think this is a way, while not perfect, because technology's hard, I think it's actually easier than our crappy compasses. You know what I mean?
Yeah, they'll be able to do this. This one won't.
I know, Joey and Doc won't. So what'll happen is you'll have to meet with me and learn how to do it, or watch the video and learn. I recorded it. And then they can take it when they're ready.
Yeah, we gotta get the others. Isabella, Joey will have to make up for this.
Right, okay.
We'll have to do that last week. Hopefully they'll have studied some.
Yeah, that's the hope, right?
Do you have a review for them to do for the quiz yet, or not?
I have the review that I gave them originally, right? Remember when we reviewed? What?
The original review?
Yeah.
You go over that with them? and-
Yep, And then I don't think I have a version 2 of that quiz made yet. I just got done making one for regular geometry. I'll have that out soon. So tell me when you need it by, and then I'll make sure it's ready
I'll
to go.
talk to Isabella and see when she'll be ready.
Okay,
Okay?
thank you. You're a good partner.